A spruce is a tree of the genus Picea, a genus of about 35 species of coniferous evergreen trees in the family Pinaceae, found in the northern temperate and boreal regions of the earth. Spruces are large trees, from about 20 to 60 meters tall when mature, and can be distinguished by the whorled branches and conical form. The needles, or leaves, of spruce trees are attached singly to the branches in a spiral fashion, each needle on a small peg-like structure. The needles are shed when 4 to 10 years old, leaving the branches rough with the retained pegs. Spruces are used as food plants by the larvae of some Lepidoptera species. See list of Lepidoptera that feed on spruces. They are also used by the larvae of Gaulodelgids. In the mountains of western Sweden, scientists have found a Norway spruce tree, nicknamed earth.Spruces, which by reproducing through layering has reached an age of 9,550 years and is claimed to be the world's oldest known living tree. Etymology. The word spruce entered the English language from the Polish name of Prussia, which was Picea. It became spruce because in Polish z-prus sounded like spruce in English and was a generic term for commodities brought to England by Hanseatic merchants, and because the tree was believed to have come from Polish ducal Prussia. Classification. DNA analyses have shown that traditional classifications based on the morphology of needle and cone are artificial. A recent study found that P. briana had a basal position, followed by P. sitchensis, and the other species were further divided into 3 clades, suggesting that Picea originated in North America. Spruce has been found in the fossil record from the early Cretaceous, 136 million years ago. Species. There are 35 named species of spruce in the world. The plant list has 59 accepted spruce names. Basal species. Picea breweriana, brewer's spruce, Klamath Mountains, North America, local endemic. Basal species. Picea sitchensis, Sitka spruce, Pacific coast of North America, the largest species, to 95 meters tall, important in forestry. Clade. Picea engelmanii, Engelmann spruce, western North American mountains, important in forestry. Picea glauca, white spruce, northern North America, important in forestry. Clade 2. Picea brachythyla, Sargent spruce, southwest China. Picea chihuahuana, Chihuahua spruce, northwest Mexico. Picea farreri, Burmese spruce, northeast Burma, southwest China. Picea likianchiensis, Likiang spruce, southwest China. Picea martinezi, Martinez spruce, northeast Mexico. Picea maximovichii, Maximovich spruce, Japan. Picea morrisonicola, Taiwan spruce, Taiwan. Picea neovici, Veitches spruce, northwest China. Picea orientalis, Caucasian spruce or oriental spruce, Caucasus, northeast Turkey. Picea purpurea, purple cone spruce, western China. Picea shrenkiana, Shrenk spruce, mountains of Central Asia. Picea smithiana, Marinda spruce, western Himalaya, eastern Afghanistan, northern and northwest India. Picea spinulosa, Sikkim spruce, northeast India, eastern Himalaya. Picea turano, tiger tail spruce, Japan. Picea wilsoni, Wilson spruce, western China. Clade 3. Picea abies, Norway spruce, Europe, important in forestry, the original Christmas tree. Picea alcociana, Alcock spruce, central Japan. Picea alpestris, Norway spruce, alpine spruce, the Alps in Europe. Rare, often treated as a variant of P. abies, distinct cones. Picea aspirata, dragon spruce, western China, several varieties. Picea crassifolia, King high spruce, China. Picea glani, Glane spruce, northern Japan, Sakhalin. Picea jezoensis, Jezo spruce, northeast Asia, Kamchatka, south to Japan. Picea koreansis, Korean spruce, Korea, northeast China. Picea Koyama spruce, Japan. Picea mariana, black spruce, northern North America. Picea mayeri, spruce, northern China. Picea obovata, Siberian spruce, North Scandinavia, Siberia, often treated as a variant of piabis but distinct cones. Picea omorica, Serbian spruce, Serbia and Bosnia, local endemic, important in horticulture. Picea pungens, blue spruce, Colorado spruce, Rocky Mountains, North America, important in horticulture. Picea retroflexa, green dragon spruce, China. Picea rubens, red spruce, northeastern North America, important in forestry, known as Adirondack in musical instrument making. Morphology. Determining that a tree is a member of a spruce species is not difficult. Evergreen needles that are more or less four-angled, and especially the pulvinous, give it away. But beyond that, determination can become more difficult. Intensive sampling in the Smithers, Hazleton, Houston area of British Columbia showed Douglas, according to Coates et al., that cone-scale morphology was the feature most useful in differentiating species of spruce. The length-width ratio, the length of free scale, and the percentage free scale were most useful in this regard. Benmeyer, after range-wide sampling, had already recognized the importance of the two latter characters. Taylor had noted that the most obvious morphological difference between typical Picea glauca and typical P. engelmannii was the cone scale, and Horton found that the most useful diagnostic features of the two spruces are in the cone. Differences occur in the flower, shoot and needle, but those in the cone are most easily assessed. Cooper et al. Recommended that cone-scale characters be based on samples taken from the midsection of each of 10 cones from each of 5 trees in the population of interest. Without cones, morphological differentiation among spruce species and the hybrids is more difficult. Species classification for seeds collected from spruce stands in which introgressive hybridization between white and Sitka spruces may have occurred is important for determining appropriate cultural regimes in the nursery. If, for instance, white spruce grown at container nurseries in southwestern British Columbia are not given an extended photo period, leader growth ceases early in the first growing season, and seedlings do not reach the minimum height specifications. But, if an extended photo period is provided for Sitka spruce, seedlings become unacceptably tall by the end of the first growing season. Species classification of seedlots collected in areas where hybridization of white and Sitka spruces has been reported has depended on easily measured cone-scale characters of seed trees, especially free-scale length visual judgments of morphological characters, e.g., growth rhythm, shoot and root weight, and needle serration, or some combination of and. Useful to a degree. These classification procedures have important limitations. Genetic composition of the seeds produced by a stand is determined by both the seed trees and the pollen parents, and species classification of hybrid seedlots and estimates of the level of introgression on the basis of seed tree characteristics can be unreliable when hybrid seedlots vary in their introgressiveness in consequence of spatial and temporal variations in contributions from the pollen parent. Secondly, morphological characters are markedly influenced by ontogenetic and environmental influences, so that to discern spruce hybrid seedlot composition with accuracy, hybrid seedlots must differ substantially in morphology from both parent species. Here and Arnott pointed out the difficulties of estimating accurately the degree of introgression between white and Sitka spruces. Introgression may have occurred at low levels, and/or hybrid seedlots may vary in the degree of introgression in consequence of repeated back-crossing with parental species. Growth. Spruce seedlings are most susceptible immediately following germination, and remain highly susceptible through to the following spring. More than half of spruce seedling mortality probably occurs during the first growing season and is also very high during the first winter, when seedlings are subjected to freezing damage, frost heaving and erosion, as well as smothering by litter and snow-pressed vegetation. Seedlings that germinate late in the growing season are particularly vulnerable because they are tiny and have not had time to harden off fully. Mortality rates generally decrease sharply thereafter, but losses often remain high for some years. Establishment is a subjective concept based on the idea that once a seedling has successfully reached a certain size, not much is likely to prevent its further development. Criteria vary, of course, but Noble and Ronco, for instance, considered that seedlings 4 to 5 years old, or 8 cm to 10 cm tall, warranted the designation established, since only unusual factors such as snow, mold, fire, trampling, or predation would then impair regeneration success. I suggested that in dry habitats on either mineral soil or litter seedbeds a 3-year-old seedling may be considered established. In moist habitats, seedlings may need 4 or 5 years to become established on mineral soil, possibly longer on litter seedbeds. Growth remains very slow for several to many years. 3 years after shelterwood felling in subalpine Alberta, dominant regeneration averaged 5.5 cm in height in scarified blocks, and 7.3 cm in non-scarified blocks, possibly reflecting diminished fertility with the removal of the air horizon. Uses. Timber spruce is useful as a building wood, commonly referred to by several different names, including North American timber, SPF, and whitewood. Spruce wood is used for many purposes, ranging from general construction work and crates to highly specialized uses in wooden aircraft. The Wright brothers' first aircraft, the Flyer, was built of spruce. Because this species has no insect decay resistance qualities after logging, it is generally recommended for construction purposes as indoor use only. Spruce wood, when left outside, cannot be expected to last more than 12 to 18 months depending on the type of climate it is exposed to. Pulpwood spruce is one of the most important woods for paper uses, as it has long wood fibers which bind together to make strong paper. The fibers are thin-walled and collapse to thin bands upon drying. Spruces are commonly used in mechanical pulping as they are easily bleached. Together with northern pines, northern spruces are commonly used to make NBSK. Spruces are cultivated over vast areas as pulpwood, food and medicine. The fresh shoots of many spruces and pines are a natural source of vitamin C. Captain Cook made alcoholic sugar-based spruce beer during his sea voyages in order to prevent scurvy in his crew. The leaves and branches, or the essential oils, can be used to brew spruce beer. The tips from the needles can be used to make spruce tip syrup. In survival situations, spruce needles can be directly ingested or boiled into a tea. This replaces large amounts of vitamin C. Also, water is stored in a spruce's needles, providing an alternative means of hydration. Spruce can be used as a preventive measure for scurvy in an environment where meat is the only prominent food source. Tonewood. Spruce is the standard material used in soundboards for many musical instruments, including guitars, mandolins, cellos, violins, and the soundboard at the heart of a piano and the harp. Wood used for this purpose is referred to as tonewood. Spruce, along with cedar, is often used for the soundboard top of an acoustic guitar. The main types of spruce used for this purpose are Sitka, Engelmann, Adirondack and European spruces. Other uses. The resin was used in the manufacture of pitch in the past. The scientific name Picea is generally thought to be derived from Latin pix, pitch. Native Americans in North America use the thin, pliable roots of some species for weaving baskets and for sewing together pieces of birch bark for canoes. See also Kiad for an unusual golden Sitka spruce sacred to the Haida people. Spruces are popular ornamental trees in horticulture, admired for their evergreen, symmetrical narrow conic growth habit. For the same reason, some are also extensively used as Christmas trees. Spruce branches are also used at Aintree Racecourse, Liverpool, to build several of the fences on the Grand National Course. It is also used to make sculptures. Diseases. Cyracoccus congenus blight. Cyracoccus congenus causes shoot blight and seedling mortality of conifers in North America, Europe, and North Africa. Under its former name, Ascocatha pinnipeda, twig blight damage to seedlings of white and red spruces in a nursery near Asheville, North Carolina, were reported by Graves. Hosts include white, black, Engelmann, Norway, and red spruces, although they are not the plants most commonly damaged. Cyracoccus blight of spruces in nurseries show up randomly in seedlings to which the fungus was transmitted in infested seed. First-year seedlings are often killed, and larger plants may become too deformed for planting. Outbreaks involving an LT 30% of spruce seedlings in seedbeds have been traced to seedlots in which only 0.1% to 3% of seeds were infested. Seed infestation has in turn been traced to the colonization of spruce cones by S. congenus in forests of the western interior. Infection develops readily if conidia are deposited on succulent plant parts that remain wet for at least 24 hours at 10 degrees Celsius to 25 degrees Celsius. Longer periods of wetness favor increasingly severe disease. Twig tips killed during growth the previous year shows a characteristic crook. Rhizosphaera coffee needle cast. Rhizosphaera infects white spruce, blue spruce, and Norway spruces throughout Ontario, causing severe defoliation and sometimes killing small, stressed trees. White spruce is intermediately susceptible. Dead needles show rows of black fruiting bodies. Infection usually begins on lower branches. On white spruce, infected needles are usually retained on the tree into the following summer. The fungicide chlorthalonil is registered for controlling this needle cast. The valsicunzae branch and stem canker. A branch and stem canker associated with the fungus Valsicunzae fr. var. Picea was reported on white and Norway spruces in Ontario and Quebec. In Ontario, only trees of low vigor were affected, but in Quebec vigorous trees were also infected. Predators. Small mammals consume conifer seeds, and also eat seedlings. Cage feeding of deer mice and red-backed vole showed a daily maximum seed consumption of 2,000 white spruce seeds and of 1,000 seeds of lodgepole pine, with the two species of mice consuming equal amounts of seed, but showing a preference for the pine over the spruce. The short-tailed meadow vole voraciously ate all available white spruce and lodgepole pine seedlings, pulling them out of the ground and holding them between the front feet until the whole seedling had been consumed. Wag attributed damage observed to the bark and cambium at ground level of small white spruce seedlings over several seasons to meadow voles. Once shed, seeds contribute to the diet of small mammals, e. g. Deer mice, red-backed voles, mountain voles, and chipmunks. The magnitude of the loss is difficult to determine, and studies with and without seed protection have yielded conflicting results. In western Montana, for example, spruce seedling success was little better on protected than on unprotected seed spots. But in British Columbia, spruce regeneration depended on protection from rodents. An important, albeit indirect, biotic constraint on spruce establishment is the depredation of seed by squirrels. As much as 90% of a cone crop has been harvested by red squirrels. Deer mice, voles, chipmunks, and shrews can consume large quantities of seed. One mouse can eat 2,000 seeds per night. Repeated applications of 500,000 seeds have failed to produce the 750 trees sought by Northwest Pulp and Power Limited, near Hinton, Alberta, but no doubt left a lot of well-fed small mammals. Foraging by squirrels for winter buds has not been reported in relation to young plantations, but Wag noted that at Hinton Ab, red squirrels were observed cutting the lateral and terminal twigs and feeding on the vegetative and flower buds of white spruce. Red squirrels in Alaska have harvested as much as 90% of a cone crop. The modus operandi is to cut off great numbers of cones with great expedition early in the fall, and then spend the rest of the fall shelling at the seeds. In Manitoba, Rowe ascribed widespread severing of branch tips 5 cm to 10 cm long on white spruce, ranging from sapling to veteran size, to squirrels foraging for winter buds. Cone failure having excluded the more usual food source. The damage has not been reported in relation to small trees, outplants or otherwise. Porcupines may damage spruce, but prefer red pine. Bark stripping of white spruce by black bear is locally important in Alaska, but the bark of white spruce is not attacked by field mice, even in years of heavy infestation.